Alright, so to sum everything up, we just took all the requirements from ASC 7, encoded it into a calculation engine, and then we either expose it via a front-end application, as you can see right here, or we expose it to an agent that can use the engine and do the calculations for us. There seems to be a lot of talk about AI agents these days. While I don't think they'll be replacing structural engineers anytime soon, I do think there are parts of our workflow where they can take on. Because a good portion of what we do follows deterministic workflows defined by the building codes, these may be ideal tasks to delegate off to the agent. One major concern we need to be aware of, though, are hallucinations sometimes made by the large language. Now, before we can set up the agent, we're going to need to solve for this first. And I plan on doing this by developing an engineering engine that our agents are going to utilize. I'll then expose it through a lightweight HTML application so you can see the calculation flow and it's a little easier for you to understand. For this example, I'll be focusing on win loads as prescribed by ASC 7. Building this was actually very easy. All I had to do was ask ChatGPT. Unfortunately, that's not how this works. Let me show you the actual engineering workflow. All right, so for the win loads, the workflow comes directly from ASC 716. Specifically chapter 26 under their general requirements, and as well as chapter 27. I've broken the process into 4 major sections, as you can see right here. First are the manual decisions that engineers still needs to make. Second are the assumptions that I've intentionally fixed for the application. And third are the dependent factors. And finally, all the calculations that tie everything together. Zooming out, every one of these steps that I just showed right here has been translated into code, creating a complete digital representation of the engineering workflow. So here's what the application looks like. All the design variables are organized along the left-hand side, making it easy to explore different design scenarios without jumping between multiple calculation sheets. As the values change, the application updates the governing parameters, intermediate calculations, and the final design pressures in real time for you. One feature that I made sure to include was to expose the intermediate values that drive these calculations. That makes reviewing results, auditing, and performing parametric studies that much faster. Of course, none of this matters unless the calculations are correct, right? So throughout development, I've been validating the results against TEDs. Let me just give you a brief walkthrough of this validation exercise that I did. So we've got an exposure category of B with a basic wind speed of 115 miles per hour. And here are the properties of my building. Now, running this through TEDS, we can see the resulting net pressures and the net forces on the structure. And then comparing against my design results on the bottom right here. Another validation scenario that I performed was with a gable roof of 20 degrees. And so here we're looking at the TEDS output for wind 0 degrees of orientation to the structure. I'll put net pressures on the left from TEDS, and then my resulting pressures on the right-hand side. Now, when we look at the scenario where the wind's being applied 90 degrees to the structure, you can see, again, TEDS results on the left, my results on the right. TEDS breaks out their forces a little differently on this wall face. It's broken up to zones A1, A2, A3. My program just lumps it all together. So to sum everything up, all we did was we went to ASC 7, found all the requirements, the factors, the tables, and etc. And then we encoded it into a calculation engine. And then what we did with the engine was we exposed it via front-end application. But in the next part of the video series, we're going to expose it via an agent assistant. And the intent and goal of the assistant is to keep it very conversational, where the agent will be able to parse out all the necessary information from you in order to complete these wind calculations. So stay tuned.